So do I copy what's there on the screen?
You have to copy the whole screen. Addition of vectors. This is what I'm putting the first topic for today.
Okay. Okay, sir, done.
Now, addition of vector, we were discussing this concept in our previous classes also. Like this was a resultant vector method, and this was also resultant vector. We did some rules on that, and the topic is there that resultant vector is the overall vector when a number of vectors are acting. When a number of vectors are acting, you need a vector, a single vector, which can actually show the output of all the vectors. The first method to find the resultant vector is called parallelogram method. The second method is called graphical, which was in O level. It was known as head to tail resolution method. The third and the most important one. So now you have to copy this screen.
Okay, sir. Done, sir.
So we are putting first the parallelogram method. Do you have the geometry box with you?
Yes, sir.
Now, look at this diagram. These are the two forces between the two vectors, and this is an angle theta. This is where you will apply parallelogram method. Actually, parallelogram method is used when you are dealing with two vectors. Parallelogram method is suitable for two vectors. Now, you have to copy this screen.
Okay.
Parallelogram method is used when you are examining two vectors, like the diagram shows two vectors F1 and F2.
Yeah.
Okay. Now remember that this method is actually a type of mathematical and geometrical work. Mathematical means using trigonometry, and
it is easy to construct a parallelogram when we know the lengths of its sides. This can be done by drawing a straight line parallel to the first vector and passing through the end of the other vector. Then, in a similar manner, we draw a straight line parallel to the other vector and passing through the end of the first vector. Now, we draw a vector of the resultant force. Its origin is located at the point where the common origin of the two vectors is located, and the end is marked by the point where the straight lines intersect. The construction results in a parallelogram whose sides are the component force vectors and whose diagonal is the vector of the resultant force. It is easy to construct a
this method is called parallelogram method. Now, parallelogram method can be done by two possible ways. You can do the parallelogram method by two possible ways. Number one, by drawing. Number two, by calculation. So when you talk about parallelogram method, there are two ways to solve it. One is the calculation method.
Yes.
And second is the drawing method. So write under it that there are two methods, there are two possible ways number one, by drawing, number two, by calculation.
Yes, sir.
Now we are starting with scale drawing approach. So give a heading, scale drawing approach. Give the heading scale drawing approach.
Okay, sir.
Now we need a protractor, a geometry box, and ruler, pencil.
Yes, sir.
This method is actually a geometrical work. In the actual paper, this topic is not common. So this is a rare topic.
Sir, I think we did this in grade 10, no?
Yes, this is coming from O level. You identified it correctly. And as mentioned that in our A level, they cover many topics. They actually connect many topics from O level, and this is the right procedure. So everyone can make a connection on that. Just like a resolution method is something which is coming from A level. So now we have an example to explain this method. We have a vector 200 Newton and we have a vector 400 Newton, and they are at an angle of 60 degree. We are there to find the resultant vector. So now you have to copy this screen, this example.
Okay. Sir, shouldn't there be like a scale?
Yes, but first we copy the question as a question and then we put the scale. You're right that we need to make a scale.
Yes, sir.
We need to make a suitable scale, and as the method says that you can select any suitable scale which is according to the size. I'm taking a scale 40 Newton is equal to 1 centimeter. Then 200 Newton will be 5 centimeter and 400 Newton will be 10 centimeter. You have to copy this screen.
Okay.
You have to update and put the scale.
Sure.
Okay. Now we can take a ruler and a pencil. What you do, you first draw a line 5 centimeter long and give some space. So better go a bit down and then start the work.
Okay, sir.
Now I put a protractor here. This is a protractor, and if you put the protractor at this position and you
Yeah.
make an angle 60 degree, now like this, put the protractor and make an angle 60 degree.
Done,
And you
sir.
make a straight line. And on the straight line, put the ruler and measure 10 centimeter.
Done, sir.
And then the entry of the compass is there. They like the compass work a lot. So now compass is there. Put the compass at this position and make an arc of 10 centimeter.
Okay.
Then put the compass on the new position and make an arc of 5 centimeter.
Okay, sir. One second.
Now the two arcs are there.
Done, sir.
Now join it like this.
Done, sir.
Now make this resultant arrow. At this point, you have drawn the resultant. R means resultant. And
Yeah.
this is to measure the value of R.
It's 13.5 centimeters, sir.
I have a range 13.1 to 13.5.
Yeah.
So that's coming in the range. Now convert it back into the actual value.
Okay.
Reverse the scale.
So it's 540 newtons.
540 Okay. So if we round it for two significant figure, it is coming 530 Newton.
So I did 13.5 times 40.
That's no problem because I'm getting the answer according to 13.2. You got
Okay.
13.5. So examiner will follow your answer because it is in the range. So within the range, examiner will make the answer, will check it accordingly. As you always remember, I hope, that in marking schemes, there are always ranges in such questions. Now let's talk about direction. This is the angle theta, which is now the direction.
Direction is 40 degrees, sir?
Did you measure it?
Yes.
Okay. If you have measured it, then it should be right.
Okay.
Theta I'm getting is also 45 degree.
Okay.
And normally in actual exam, when this topic comes, there is always a range. Answer for angle, when you give the angle in degree, the answer should be correct to 1 decimal place. Angle in degree should be correct to 1 decimal place.
Okay, sir.
Now, this is the second example. You have to copy this example. After copying the example, mark
Yes,
it
sir.
for homework.
Okay, okay, sure.
This will be our first homework. Now, give a new heading, calculation approach.
Okay, sir.
Calculation approach means using trigonometry. This is more important in the new syllabus. Our syllabus got revised last year, and this was a big revision in the syllabus. So last year onwards, even after 2016, when there was another syllabus revision, this topic, which is called scale drawing, is not very important now. Even in O level, this topic was not important. So this happens in every syllabus, in every chapter, that some topics are important. Definitely, a scale drawing method cannot be given in paper 1, but in paper 2, it can come. Now you look at this diagram, calculation approach using trigonometry. Now, this is the example. You have to copy the first example.
Okay.
Let me know once you have copied it.
Done, sir.
Now, let's discuss this method. This is a pure trigonometry method. So the diagram is fine like that. Angle is 70 degree. Now I draw a dotted line like this. So you can work with me and you can draw a line which I have drawn.
Okay. I have to draw, sir?
Yes, you have to you have to add this dotted line.
Okay.
And then make a connection here. Look, if this angle is 70, now look at this point. If this angle is 70, if this angle is 70, why this angle is also 70?
Because
Parallel lines.
yeah, parallel
Good.
lines are
The two angles are equal because the two lines are parallel, corresponding angles in parallel lines. So you update like this. And then you draw a green dotted line and mark on it angle 110. Can you tell me how this angle 110 came up?
because 180 minus 70. Sir?
Yes.
Sir, it's because it's 180 minus 70, the angle
Very
110.
good. And this is called as supplementary angles, angles on a straight line. Good.
Yeah.
That's good. Now I have marked R. R is the resultant. Now I'm looking for our O-level friend cosine rule because it can tackle this situation. In order to simplify the diagram, you can also now shift to this triangle. This is a bit simpler triangle. So remove the extra lines or draw this diagram again for simpler version. Extra things are removed. And now we are looking for capital R.
Okay.
Now copy this screen.
Done, sir.
Now work out this formula for me and try to get the answer.
Sure.
The calculator should be in degree mode. Compare the answer once you get it.
Okay. 107.87.
107.87. So let's make it 108.
Okay.
Now we are talking about theta. Theta is the angle we have marked here. And theta is coming here for direction.
Okay.
Now, what
Sine.
should be our plan? Sine rule is there to help us because sine rule is actually expert in finding the unknown angle. We have the quantity now. We have the value of R with us.
Yeah.
So use sine rule.
Okay, sir.
What I'm getting is 44.2.
1 second, sir. Yeah, 44.1 I got. Sir.
Are you getting the same answer?
So I'm getting 44.1.
That's fine. 44.1, 44.2. Now apply cosine rule for magnitude. There's an error in typing and cosine rule is normally used here for magnitude and sine rule is used for direction. So you have to copy this screen.
Okay. Done, sir.
Now we have to put our second example. We have to copy this example.
Okay. So is this for homework?
Yes, you have to. Yes, this will be homework, but you have to first copy it.
Sure. Okay, sir.
This is called the trigonometry method, and this method is based upon the same idea that you can convert the given question, in a triangle, and once you get a triangle, you can solve it by sine rule and cosine rule. These are the answers, but we can check in the next class then. Okay, now give a new heading, graphical method.
Done, sir.
Graphical method is famous in our O level, and if in O level physics also, in O level maths also, this topic was famous by a concept called head to tail. So I'm using the same word because majority people remember it by this name. So you have to copy this.
Okay. Done, sir.
Now, look at this thing to recall. This is the vector, and head to tail method was known by the idea that you connect the vector in such a way that one vector head comes on the tail of the other vector. And what was the way to identify the resultant? When you are adding the vectors, they are always head to tail, but the resultant vector is always head to head. So this was our O-level memory, and in O-level physics, O-level maths, this topic was there, that vectors can be added head to tail. Look at this short animation. I move the red arrow here. Now I make the resultant. Why I am moving the red arrow here? Because now I can make the resultant, because resultant is head to head. Vectors being added are head to tail. This is a memory to come back. Okay, now you have to copy this screen.
Okay.
I'm just coming. Copy this screen. I'm just coming.
So x plus y equals to r, yeah?
Now we put the concept that the vectors being added are head to tail. We're putting our next concept for today. It's a callback. Vectors being added are head to tail. And the resultant vector is head to head. This was something which we used to, this was something we used to identify the resultant vector in O-level maths and O-level physics. So now you have to copy this screen.
Okay. Answer.
Now I'm putting this example for practice, and you just copy this example.
So do I copy this?
Yes, you have to copy and solve for me.
Sure. Sir, what do you mean by when resultant vectors are like equal to head?
Actually, this is a diagram feature. If you look at this diagram, it's actually how to identify which is the what are the vectors being added. Now look at this. This is head. This is tail.
Yeah.
This is the tail. This is the head. For this is the tail and this is the head. Now look this one. It means this vector is the resultant and these two vectors are being added.
Sure. Okay.
So this is a way to identify. This is a way to identify which vector is the resultant and which vectors are being added. Now look at this diagram. I have made the diagram updated and you can see the double arrow. It's not an actual way to represent, but the double arrow vector is the resultant vector. If you proceed on the green line, you will see that it is colliding with 7 Newton vector. So 7 Newton and R are the meeting vectors. 5 and 7 Newton vectors are being added and the green vector is the resultant vector. Its direction is very important. So update the same screen and solve. You can use trigonometry, Pythagoras theorem.
Okay. So it's 8.6 the magnitude? 8.6 is the magnitude, right?
Yes. And now forward for the angle.
Okay. $54.5 is the angle. Sir?
Yes. You can look at the screen.
Yeah, 54.5. Yeah, I got it.
Yes. Good. So now these are the examples. Sometimes the question can be more than one vector, like more than 2 vectors. So this is an example. Actually, head to tail method can be used for any number of vectors. This is a specialty. But normally in MCQs, at least, we do not need more than 2 vectors. This is a case where you can see resultant vector is being asked for more than 2 vectors. The method is the same. You can take a scale because now trigonometry would be difficult. Trigonometry works only when you are facing a right angle triangle like this. But if you're facing something in a 3 or 4 vectors, then you should go for scale drawing. You first make the first vector, then make the second head to tail. You make the third head to tail, and then you draw the resultant vector. This is called vector addition by head to tail. Now we move to resolution of a vector.
Okay.
Give this heading resolution of a vector and mark it very important. This is a very important topic in our course. Resolution vector, a resolution of a vector is a very important topic and it comes in every paper. So you should mark it. This is a procedure I always follow, that we will keep on marking important, unimportant, rare topics. So parallelogram is a rare topic. Head to tail is less common. Resolution is a very important method. Now first make the concept of resolution vector. When something is moving on an inclined surface, for example, this is a slope like a bridge.
Yeah.
And you are going on the slope. When you're traveling on the slope, you are actually making displacement horizontal and vertical.
Yeah.
When you are traveling on a slope, you are actually making horizontal and vertical displacement. So there comes the concept that whenever there is an inclined vector, it actually travels, it actually covers two components. One is called horizontal and one is called vertical. Another example that, for example, these are the staircase and you are going up the staircase on this way. Actually, you are traveling some horizontal and some vertical. When an aeroplane is taking off, the velocity of the aeroplane is taking the aeroplane forward as well as upward. So when an aeroplane is taking off, the velocity is taking the aeroplane forward and upward both. These are called the two components of the vector, and this concept is called resolution of a vector.
Yeah.
We make this concept our first in this article. Every inclined vector can be decomposed into its perpendicular components. This is called resolution of a vector. You have to copy this
Sure.
screen.
So what do you mean by inclined vector?
Incline means slope.
Okay.
Incline means slope. Whenever you reach a slope, like when a bridge starts or when you descend from a bridge, you need a slope. The word inclined actually means slope. So when you are having something like this, this is called inclined. This is called horizontal. This is called vertical.
Sure.
Now you have to copy this screen.
Done, sir.
This is called the inclined vector. It's a force and the angle is theta. Now, not discussing the trigonometric detail, as again that is a right angle triangle case. When we resolve a vector, we put a cross, double line cross like on the vector, and on one axis we write cos component, and on other axis we write sine component. Actually, sine and cos are coming because sine is opposite upon hypotenuse and cos is adjacent upon hypotenuse. This is how we resolve a vector. This is how we resolve a vector. Now, you have to memorize something important, that when you are making a diagram, you can find an angle. Where the angle is, that adjacent component will take the cos, and where there is no angle marked, that will take the sine theta.
Sure.
One component will take the sine theta and other component will take cos theta. You have to copy this diagram now.
Sir, like, how do you know that which angle should be used as the direction?
No, angle will be marked.
Okay.
Angle will be marked, and this is again a concept of additional mass. And I think you have done mass obviously, but you have not done add mass, so it's not. I'm
Yeah.
getting into that discussion, but actually, what happens that when you draw a diagram like this, and you say this is 60 degree, then logically this will be 30 degree. If this is a cos function, then this will be a sine function.
Sure.
But that detail is not needed because they don't ask it. So you simply remember it, that when they mark an angle, you will put cos there. It will further clear in the coming slides. If there is no angle mark, you have to put sine there.
Sure. Done, sir.
Now look at this example. Look at this example and look the angle. Angle is marked 45 degree. So this is 20 cos 45. The vector is 20. And this is 20 sine 45. This is how every vector can be resolved. So give us side heading. Example 1. Give us side heading, example number 1, and copy this screen.
Sure. Done, sir.
Now look at this example, and once you solve it, you will get 10 cos 30. You will get 10 cos 30 and you will get 10 sine 30. Now look at this very important concept. Can you notice the angle is now with y-axis?
Yeah.
Now look at this screen. Cos component goes on y-axis and sine component goes on x-axis. Now the rule should be remembered. Again, there's obviously trigonometric explanations are there, but remember that when you mark theta, where you mark theta will be cos, and where you have not marked any angle will be sine. So now copy this screen.
This is example number 2.
No, this is not exact. This is a new concept.
Okay. And that's it.
Have you copied it?
Yes.
So this is the idea. This is the idea of dealing with the resolution of vector. We just keep it up to here. And we will, inshallah, continue this in our next class. You just give the heading. So we have a connection for next class, resultant vector by resolution method.
Sure. Done, sir.
So it's over for today, and we will, inshallah, continue it in our next class. Thank you. Allah Hafiz. Bye.
Bye.